Everyone, and welcome to lesson 1.7, day 2. Today we are going to talk about writing two-column proofs, but we're going to connect it with using algebra. So you see here with algebra, we have been doing a lot this semester already with solving equations, and when we've done so, we've used things like the addition property, subtraction, multiplication, division, and distribution to solve these things. We also have a couple extra properties we haven't probably talked about too much, but they are something that we know is true. For instance, the reflexive property is saying that something is equal to itself. The symmetric property allows you to write something in reverse order. For instance, like if I said x equals 7 or 7 equals x, we know that that's equivalent to each other. The transitive property tells us if two things are equal to the same thing, then we are allowed to say they're equal to each other. So for instance, both A and C are equal to B, so we could say they're equal to each other. And that's similar to the idea of substitution, that if we know two things are equal, we could substitute in that value into an equation or inequality. So keep these in mind throughout the next couple of lessons and today's notes. Now, in example 1, we go back to what we've been doing this semester in solving our equation. This time, though, they're asking us to actually justify each step. So oftentimes we like to start by either adding or subtracting the smaller x value to each side if necessary. So in this case, we can add, okay, so addition property, to both sides the 1/2. So we get 4 halves or 4.5 or 4.5 x's plus 9 equals 18. And then we use subtraction to move the the 9 over. So again, we would say the subtraction property. And then when we divide, so again, division property, we can actually get our final value for x, which is 2, right? So what we see here is the actual writing of our reasoning before this. Okay, so we see again down here with William's example, his own setup for solving his equation. He used the distributive property to distribute the 6. He subtracted the 84 over, simplified. And then here's where William went wrong. He said that he used multiplication. We know that he used division to make x equals 4 because he divided both sides by 6. So again, he used the division property, not multiplication. Now, we know sometimes order can be a little different. Again, sometimes you may start with moving your constants, not your x values or vice versa. Maybe for this particular example, something that could have been done is that William could have taken this 6 that was out front, and maybe he would have started by dividing both sides by 6 as opposed to distributing. So sometimes can we make these in a different order but still get to the same end result? The answer there is yes. Now, we've been talking a lot about inductive reasoning and making conjectures. What if we actually want to prove without a doubt that something is true? And again, that's going to come with deductive reasoning, where we can prove without a doubt that something is true. And oftentimes what we do is we create a theorem, which is a conjecture that we prove true, through the use of a proof, which is our argument through deductive reasoning, showing without a doubt it's true. And oftentimes in geometry, we like to organize this in a two-column proof format. So we're going to practice today using our algebra skills to do that. So here is our two-column proof, statements on one side, reasons on the other. And each time we begin our proof by writing down our given information. So first step was given to us, and eventually we are going to try to prove that x equals -3. Now notice this proof starts off that this -1 moved over to the right-hand side through addition. From there, we see that the 3 was distributed to the x and the 2 through the distributive property. And then from there, we took the 3x, and notice that was moved over through subtraction. Then we took the plus 12 is no longer there. We moved it over to the other side through, again, subtraction. Finally, we divided by 2. So we use the division property. And then last but not least, we can flip that order so that x does in fact equal -3. Again, that's going back to our symmetric property that we're allowed to rewrite that. So we would say the symmetric property. In our next example, then, we have this given information this time, and we're ultimately trying to prove that x equals 9. Now, notice on this one, what they're doing on both sides is they are multiplying both sides by 10. So we would say multiplication as our first step. Next, they simplify. 10 divided by 2 is 5. 10 divided by 5 is 2. So you could say simplify, because we simplified on each side individually. Next, we took this 5 and distributed to the x and the -3, and the 2 got distributive to the 6 and the x. So we would say again, distributive property. Subtract this 2 over. So we have subtraction. Add this 15 to the other side. So addition. And last but not least, through the division of both sides by 3, we resulted in x equals 9. Try this last example on your own and make sure you write down your given and then follow through the steps to ultimately get your final 2-column proof.